definite now. And we'll go back and forth. Okay, so let's look at a definite integral. Yes, one caught my eye. Here it is.
So for a test, when we're doing substitution, will we then have to prove it using?
No.
Okay.
It's up to you. It's up to you if you want to check, but I will not ask you to check. But I needed to show you that this is very easy to check. So 65 caught my eye, the integral from 1 to 2, from e to 1 over x, divided by x squared dx. What type of integral is it?
Definite.
Perfect. The answer would be?
A number.
Excellent. What is the next step I have to check? That it's continuous. Is it continuous? Yeah, it will not be continuous at 0. Only 0 is the problem, and 0 is not between 1 and 2. Perfect. Good. So what bothers you when you look at this function? Can you say, and this is not a scientific way, I have to admit, it's not a scientific way of finding the substitution, but it's a legitimate way of thinking. What bothers you here?
E to the power of 1 over x?
Yes, especially 1 over x inside e. Yes, so that's my starting point. Okay, I'm going to set let u be 1 over x. As long as du is in the problem, or just a number is missing, a factor is missing, and I can always make that up. Always. So can anyone give us du? Because without du, I can't proceed. Because I want to change from dx into something with du. I have to have du here, otherwise I can't continue.
Negative 1 over x squared.
Negative 1 over x squared. Not enough. Perfect.
Dx.
Dx. Do I have this? Yeah. Who cares? This number I can make up. No problem at all. Multiplying twice by negative 1 doesn't change anything. So here is my du. Yay! So then what is this? And I'll put it here.
EU over.
I need to replace this. I already have the u, the negative, the x squared, and the dx. All pieces are there. They're here. I only need to replace this.
Would it be e to the u?
Exactly. That's all. Do not copy the limits of integration, please. So now I have to find the limits of integration for u. They cannot be copied from the limits of integration for x. So when x is 1, what is the lower limit for u?
1.
Excellent. When x is 2, what is the upper limit for u?
Half.
That's it. What function prime is e to u?
E to u.
Excellent. From 1 to 1/2. I plug in 1/2, which means the square root of e, minus, when I plug in 1, I have e. Final answer. Notice that with a definite integral, we do not go back. With the indefinite integral, I have no choice. I cannot leave the answer in t. I have to give the answer in the variable the function was given to us. The function was given to us in y. We chose something in the middle to help us solve. Who cares? Nobody cares. The answer has to be in y. But that's why I always ask my students, what is this? And you already said it's a definite integral. Then I ask, what is going to be the answer? A number. So because it's a number, who cares if I work in E or U or T or Z? Nobody. I don't have to go back to the substitution, but I have to determine the correct limits of integration because otherwise this will be incorrect. So with the definite integral, please don't go back. There is no point. Okay, next problem.
What happened to the negative that we applied?
Nothing. I swallowed it. Thank you. A written apology. Sorry. It must count because it's in public. Must count more. Of course, nothing. My brain is working forward and not looking where I should be looking. My apologies. Absolutely. I've omitted to copy it. My mistake. Sorry about that.
No problem.
Sorry. So the integral from 1 to 2, from x, the square root of x minus 1 dx. Okay, we don't do anything. We just check. First of all, it's a definite. I know you're going to say it's a number. I know you're going to say it's continuous because x minus 1 has to be greater than or equal to 0, and that's fulfilled here. So continuous, no problem. Okay, then. Now, I'm going to ask you again what you don't like here. And I don't like any function inside another function, especially with the square root. Because the square root of a minus b cannot be simplified. Like this, a minus b, the square root. It's fixed. Nobody can change this unless it's factorable and yada yada. So this is what bothers me. Like here, this is what bothered me. 1 over x inside of e to the x, and now this changed into another function. That's complicated. Same thing here, so to speak. This is inside another function. So I would like to say, let y be x minus 1. Because I can handle the square root of y, but I cannot handle the square root of x minus 1. This is okay. This is y to 1/2. But this I cannot do anything to it. So that's my problem. My problem is having a function inside another function and not be able to simplify. Again, the square root of y, because this will become the square root of y. This is friendly. It's y to 1/2. I can handle that. What is the next step after I choose my substitution? Which could be the right substitution or not. So
Find dy.
dy, excellent. What is dy?
1.
Okay, the derivative is 1, but dy is?
dx.
Yes, 1 times dx. It could have been nicer. Brilliant. So I have the square root of y and I have dy. Let's not jump to conclusions. This has to be replaced somehow. I cannot move from x to y and still have x. That's not possible. Every integral has to have only one variable. This one has variable x. The next one, when I move to, it has to have only variable y. So the question is, what do I do with this, and what do you think we should? I cannot erase it or ignore it or copy it. Oh, no. It has to be in terms of y. Is there any way we can write that? X in terms of y and y only.
Would it be x equals y plus 1?
That's it. This becomes y plus 1. Exactly, by solving this equation for x. So x equals y plus 1 from here. Awesome. Brilliant. Thank you. So now I am free to move, completely move from x to y. The integral, this piece is y plus 1. This piece is the square root of y. That piece is dy. Brilliant so far. Careful, please. When the lower limit for x is 1, what is the lower limit for y?
Zero.
Excellent. When the upper limit for x is 2, what is the upper limit for y?
1.
And we are not looking back. I don't care about all this anymore. That's all I need. Why? Because it's a definite integral. So now you can say, what did you accomplish? A lot, because now this I can distribute easily. The integral from 0 to 1, this is power 1/2 multiplied by this. So this is power 3/2. This multiplied by this is y to 1/2. And this is so much easier than this, which I couldn't do anything with. Good. So then y to 3/2 plus 1 over 3/2 plus 1 plus y to 1/2 plus 1 over 1/2 plus 1. And this is so nice, from 0 to 1. I only plug in 1 because when I plug in 0, this becomes 0, this becomes 0, so I only plug in 1. 3/2, this is 5/2, 2/5, because this is 1, plus 3/2, 2/3, because this is 1. And minus 0, but I don't have to write it, because it's 0, 0. The least common denominator, 15. This one needs a 3, and this one needs a 5. So 6 plus 10. Great job, guys. Okay. I'd like to look at least one more. Let's say 50. 50 caught my eye. The integral from x over 1 plus x to the 4th dx. Yes, this is a family of functions. This is not definite. It's not definitely between this and this, so it's going to be a family of functions. Don't forget the c, the constant c. And now let's think what to do. Now, if you say, I don't like this inside of a fraction, that's not going to work. Because dt will be 4x to the 3rd dx, and there is nothing I can do. I cannot make an x to the 3rd out of an x dx. This is not going to work. Next, I'm still looking here, and I see that this is x at the top. Do you have any suggestion? I'll wait for a second or two if you have any suggestions. So I'm looking at this, and I'm also looking at the fact that this is x. And I also have in mind, when I see something like this, I do have in mind something like 1 plus x squared, right? Because I have a function in my mind, which is the arctangent of 1 plus x squared. But I don't really have 1 plus x squared. I have 1 plus x to the 4th. So I'm thinking of this, and I'm going to say let t be. What do you think?
Arctangent squared.
Just x squared. just x squared. But this is the antiderivative. I'm not there yet. I was thinking about the antiderivative of this, which is the arctangent. Okay, so let's get on this path. Can anyone give us dt?
To x to the dx, or times dx.
Excellent. I love it. I love it. So all these are done. Who cares about a 1/2 in front? I may forget about it like I did with a negative. Maybe not this time. Okay, so this is 1/2, the integral from. The top is dt. I cannot copy any x. What will I copy for this underneath here in terms of t and t only?
Would it be t squared?
But you mean
1 plus
1.
t squared.
Yes, awesome. And this is what I was getting at. So then 1/2 in front. What function prime is 1/1 plus t squared? We used it before today.
Arctangent.
Very good. It's an indefinite integral. I have to go back to the variable. I have to replace t by x squared. It's a must, because this is an indefinite integral, and the answer has to be given in the same variable. But who cares if I have to find a number? Who cares if I solve the integral in t, z, a? Nobody cares. It's the same number no matter what I do. Okay, but here I have no choice. So I have 1/2 arctangent x squared plus a constant c. Any questions?